Hey everyone, if you are enjoying these videos, go check out my website at www.apcsexamprep.com. I have information on boot camps and tutoring availability along with other AP Computer Science resources I think you'd enjoy. Hello and welcome to 1.5 of AP Computer Science A, CodeHS 2025 edition. So we're talking about casting. So when you assign an integer value to a double, Java automatically converts the integer to its decimal form. So here we have y as a double equaling 5. So that'll automatically convert it to 5.0. And so when you print, it would print 5.0. Now sometimes you want to convert that double into an int value. And so casting is converting one data type into another data type. So if we have x equal 10 and then y equals x, well, since y is a double and x is 10, y would convert that 10 value to 10.0 as well. But that only works when an int is converted to a double, and automatic widening, as that might be the technical term, but you won't see that on the test on the AP exam. But this is what it's called when you automatically convert that int to a double. However, here, when you're dividing two int values, the result is only the integer portion of the quotient. So 10 divided by 4, this does integer division, as we've gone over before. So 10 divided by 4 would truncate or round down. So 10 divided by 4 should be 2.5, but it would round down to 2. And so that 2 value would be an integer 2, but then the widening would cause z to equal 2.0. So there are the steps right there, and 2.0 would be the end value for z. So if you want to change an int to a double, we do our casting, right? So if you want to make your calculation more precise than being 2.2, you want it to be 2.5, you need to make sure at least one of the values is a double. And so you can use them as literals and make 10.0 divided by 4. So what if you have two int values that are getting divided? Well, that would be an example of when you need to cast to a double. And so you do that by putting a double in parentheses before the variable that you want to cast. And so x would be cast to a double before the division happens. So to cast an int to a double, you use the casting operator double right in front of the value you want to convert. So as you see, that would divide correctly into 2.5. Now, if you already have 24.5 and 5, you wouldn't need to do anything, but here the x value is cast to an int before the integer division happens. So 24.5 does become 24, and then you do division, integer division, and so 24 divided by 5 would be, I think it's like 4.8. But then it's integer division, so it would round down to just 4. Okay, yep, right there. All right, so now we have double x equals 10.3. We cast that to an int, so it becomes just 10. So y would equal just that 10 value. The y would be 10. The x is temporarily cast to an int value, but when we print, it doesn't reassign x to an int value. X is still 10.3. It's just temporarily reassigning this to be 10 at that point in time. So when we're rounding, it does become a little bit tricky. You might see this on the AP exam. I haven't really seen this on practice exams before. Maybe on like a Barron's practice test, but it is something that can be useful to know, is that when you want to round correctly, you need to add 0.5 to our x value, which is a double, before you cast to an int. So this would be rounding correctly. So round up if it's 2.5 or 0.5 or greater, and then rounding down if it's less than that 0.5 value. So if we have 2.2, we don't want it to round up to 3. We would want that to round down if we were rounding correctly, rounding to the nearest. And so doing 2.2 plus 0.5 would only reach 2.7. And so when we cast it to an int, that would still round down to 2. So we would still get the correct value. So you might wonder, why would we add that 0.5? Well, if we have 2.8, we would want that to round up. If we add 0.5 to that value, it would be greater than this integer 3. It would be 3.3. So then when we finally cast it to an int, it would round down to the correct value. And that works for any value that needs to be rounded to the nearest. If it's a negative number, it just works a little bit different. Because int values truncate the decimal, they technically don't round down, they just chop off the decimal. So if it was a negative number, technically that would be rounding up by chopping off the decimal, because it would be a lower negative value. So with a negative value, you would want to do minus 0.5. So negative 2.8 should round down further to negative 3. So you subtract 0.5 from that to make it go to negative 3.3, and then cast that to an int to be negative 3. Again, you don't see this a ton on the AP exam. I have not seen a specific question that I can remember that is that, but good to know. And needed for CodeHS. So here, 3 values, rounding correctly to the nearest. We want to investigate, focus on the expression right of the assignment operator. What part of the expression is evaluated first? What is the result? So yeah, in the parentheses, it gets evaluated first, then we cast it to an int. Okay. What part of the expression is evaluated second? Well, the casting to an int. What do you think would happen if you change line 10 to have no parentheses? So value 2, of course, would be cast to an int first, and that would cause it to be an error because you'd be trying to have this rounded to be a decimal value, and that would be incompatible types. And there we go. We have error incompatible types, possible lossy conversion double to an int because it's trying to say value 2 becomes 10 because this would happen first, and then adding 0.5 would cause an error because we're trying to have rounded be an int value, but it would be seeing it as 10.5. So definitely wouldn't want to do that. So make the change and then run the program. What happens? Why? Add the parentheses back to 10. Yeah, so we just did that. Modify, create a double variable named value 4 and assign it to a negative number. Okay, double value 4 equals negative 10.5. Let's put it right on there. Do the int rounded 4 equals int value 4 minus 0.5 to get it correctly rounded to the whole number, and then copy, paste, 4, don't forget a semicolon. And there you go, negative 10.5 should round to negative 11 to round to the nearest there. So we check our code and we are good to go. So then submit. And now on to the quiz. So what will this expression evaluate to? So casting 9.9 would cast it to an int. This would happen first. 2 times 2 is 4. What is the value of the following expression? This would happen first. So it would be 2.25. Cast to an int would be 2. And then int x equals 9. Double y equals x. So y would equal 9.0. Still a double because of the widening. Would still convert x to a double, but it would be the value of 9.0. So x is, so double x 2.5, y equals int x. So this would be 2 times 3 is 6 as an int value. 2, 7, and 7 divided by 2.0 would be 3.5. I had that backwards. So when you cast at least 1 to a double, then the result will be a double and divided correctly. So following code segment is intended to round num1 to the nearest integer. So 34.6, missing code, print rounded num1. So the missing code would be the +5, so that it would round to 35. And you'd want to put that in parentheses because you want to do that first to make sure we reach that 35.1 before we cast to an int to get 35. All right, movie ratings. So ask user for a movie rating as a decimal, round the decimal value to nearest int, print the rounded value. Easy enough. Okay, so system.out.println. Enter movie rating as a double. And then we need to put our scanner input equals new scanner system.in. Then a double rating equals input.next double. And then system.out.print rating rounded :space plus rating, and then we want to cast it to an int, and we want to also make sure it rounds correctly by adding 0.5, like that. 1.7 to test if it rounds up correctly. Pretty sure it's going to round down correctly, so I'll just check my code after that. And it works. So we submit. You're decorating one of your bedroom walls. The height of the wall is 8 feet. Write a program that helps calculate the number of rows of pictures you will need to cover your wall depending on the height of each picture. Total number of photo rows, including any partial rows that can fit on the wall. This value should be stored in a double. Total number of complete rows that can fit on the wall. The remaining inches that will be left over. Print these values with a descriptive message. Okay. So system.out.print what is the height of each picture? Scanner. Input.next int. Total rows, including partial rows, so as a decimal. Eight feet times 12 inches would be, what, 96 inches? So including partial, 96.0 divided by inches. I'm going to need another set of parentheses to make sure that we do this calculation first. If you left out the parentheses, it would turn 96.0 into a string, and you can't divide a string or text by a number of inches, so you would not want to do that. And then next is complete rows plus 96 as an int divided by inches. And inches left over plus parentheses 96 mod inches would get the remainder. I believe that's what they want. So let's run this. Oh, they wanted us to create 4 int variables. So int inches, int height equals 96. So height. Oh man, they want us to do the math for each one of these. So I guess double including partial equals the math of double height divided by inches, int complete equals height divided by inches, and then int leftover equals height mod inches. So just split that up into variables, and then we'll just call the variables by name, including partial, complete, leftover. And so we'll check that again. Same calculation, so I don't think I need to rerun the program to test it. I'll just check the code and see if they like it. Now they're being specific, but it is proper programming to break those into variables so that you can reutilize those later. This is just such a short program that does it really matter? No, but on bigger programs it's nice to be able to specify what values. If you make a calculation, you don't want to have to do it over and over and over again. So the height of each picture is 7. And there's our answers. Check our code. And there it is. So when you assign a value to a variable, you are actually using computer memory, and they store it in binary. So this is what the value 10 would be stored at in binary. So even though it only uses some of the bits, the computer sets aside 32 bits because integers have to have limits. Otherwise, you'd be using a infinite or an unknown amount of storage for storing values. So ints can only store 4.294 billion values, and so negative 2.147 billion up to 2.147 billion and some change. So since the range of possible numbers is predetermined in Java, there's preset values that you can use to represent the maximum and minimum. And so you might use integer.max value so that you are making sure that every value is less than that. So here would be utilizing integer.max value. If you printed it, it would be this value, 2.147 billion. But what happens is when we run out of storage, it becomes the lowest number. It overflows and wraps to the lowest possible value. So when we do max plus 1 and print x, it would both print 2.147 billion first, and then the next time x would print negative 2.147 billion. So as you see here, these would be the two values for the max and then the min when you add 1. So storing a double, there are only a certain number of bits, 64, to represent that decimal value. So when you have a decimal value, there is also a limit on the number of decimal values that it can store or show. And so a decimal could be an infinite number of values between even 0.1 and 0.2. It could be 0.11, 0.111, 0.1112, 0.1113, and so on and so forth. So it can be so many different values, that an infinite number of values, so there's no way it can store every single value. So because working with ints does not result in the same rounding errors as doubles, consider using ints when possible. Well, this is why you try to use, you don't always use doubles, and you only cast ints to doubles when it's necessary, both for the memory purposes and also to avoid rounding off errors. So while this is out of scope for this course, many programmers use the big decimal class when they need exact decimal representation. Similar to the scanner class provides tools for getting user input, the big decimal class provides tools for performing high precision arithmetic, basically giving you more bits to be able to have a higher accuracy on your decimals. So we want to print the following: the minimum value for an integer, the maximum value for an integer, the minimum value minus 1, the maximum value plus 1, the maximum value multiplied by 2, the minimum value divided by 2. Okay, so int min equals integer dot min value min minus 1. And we haven't done max times 2. Min divided by 2. And there we go. Alright, we've deployed an interplanetary currency called Solari. It has quickly gained popularity. 1 Solari buys many US dollars with the following conversion. Converts dollars to Solari and then reflects on a floating point round off error you observe. Create a variable, store the conversion rate. Equals 0.034567. A variable to store the amount of dollars to convert and assign it the value of okay, so double dollars to convert. I don't know if they want an int or a double, but looks like it's 100,000. Stores the converted amount in Solari. Double Solari. Dollars to convert times Sol. I guess it's per dollar. Not $2. It's the other way around. So I assume this will give us some sort of, I don't know why I capitalized this. Variables should always be lowercase, lower camel case, so we want to make sure that we have that. Well, first I want to see if I run this. And that's what they wanted, so very good. Alright, and that is it for 1.5 on CodeHS AP Computer Science A 2025 edition. I hope you enjoyed the video, and don't forget to check out my website apcsexamprep.com where you can get more information on boot camps and tutoring availability.